Welcome everybody to the first of the Vulkan sessions for this GDC 2018. We have 4 sessions planned this afternoon. This first one is kind of an overview. It's what has happened recently, what is the state of Vulkan today, and what have we been working on. Then after the break, Hai Nguyen has organized a session which will be a deep dive on what's happening with HLSL support in Vulkan. Sound check, am I okay in the back? Sounds a little funny. It's all right? Yay, thumbs up. Cool, thank you. 4 o'clock, we have a session on Vulkan on Android. And then at 5:30, Dustin Land will talk about how, incredibly, he managed to port Doom 3 to Vulkan despite knowing A, nothing about Vulkan, and B, nothing about graphics when he started. An amazing achievement and a great story. And we'll use that as a springboard to talk about what actually is hard and what is not hard about working with Vulkan. So this first session, I'm Tom Olson, I'm chair of the Vulkan Working Group. I'm going to present for about half the session a working group's eye view of the state of Vulkan today and what we've been doing for the past year or 2 and where we're going. Then David Neto of Google, who's the chair of the SPIR-V group, will talk in more detail than I can about progress with the language tool chain. Finally, Dan Ginsburg from Valve will talk about the Portability initiative, which is our effort to move Vulkan beyond the platforms where we can ship native drivers. So, where are we today? Well, it's been 2 years since Vulkan launched. We are slowly building out. We've had conformant drivers since the day of launch, but they were crufty and not very available. Availability today, we think, is pretty good. By the way, I'm going to say all these things. You have to tell me if they're not true. Okay, well, there will be Q&A, but this is what the working group thinks is true. So we have drivers, and on the desktop, these are all production drivers. They're shipping. In many cases, if you run Windows Update, you will end up with some flavor of Vulkan on your machine. Not universally true, and there are, gotchas there, but that's generally the case. Of course, Windows Update will give you a driver that was new 6 months ago or longer. And so if you want something newer, you go to a vendor website and install what they've got. There are drivers from all of the mobile vendors now. Broadcom is the latest to join the club. And very exciting, open source drivers. We've had the ANV driver for Intel for a long time. RADV driver became conformant earlier, I think it was last year. Platform support, it's great on Windows 10. It's pretty easy to get a driver. It's a little spottier on the older versions of Windows. Linux, the Mesa team has, as I said, they have ANV and RADV in their main line. I'm hoping Jason Ekstrand is, I get my information from him. I'm hoping I'm quoting him right. It's not entirely all in distros yet, but it's the same problem with Windows Update. There's a pipeline before you end up in a Ubuntu or Red Hat distribution. And of course, we're very happy about the Android situation where Vulkan is standard and has been shipping for quite a while. I have grayed out there macOS, iOS. Dan Ginsburg will say more about that later. Game engine support. Again, it's kind of a steady incremental build out. We're seeing more and more engines that have Vulkan paths in them. They've been around for a long time, and there was support in Source 2 at launch for Vulkan 1.0 2 years ago. But what we're seeing is that it's becoming more and more production. Now, it varies widely. On some of these engines, Vulkan is not the preferred path, and your gamer has to go in and explicitly enable it, and maybe it'll work, or maybe it won't. In others, it is production, absolutely, and it's the preferred way to view your content. And so another thing that's new this year, last year we had engine support. This year, there's quite a number of games using it. This includes even, I don't know how long I'll get to say this, but at launch, Wolfenstein 2 was Vulkan only, which is kind of cool. I'm sure, as I say, that won't last. There's a lot of stuff that is ports of console and DX11 games to Vulkan for Linux. And in general, things building out pretty well. Also, I forgot, mobile, because of the fact that Vulkan is explicitly exposed from Android O on, there's a lot of content coming out there. Have to keep my clock awake here. We look at other things besides, that's sort of the commercial momentum. Things that we look at a lot is what's happening in the developer ecosystem. So, for example, thanks, Karen Gavam of LunarG keeps feeding me statistics on downloads of SDKs. It's quite noisy, as you see. There's a big spike every time a high-profile game comes out, or an update, or a press release, or a new extension. But the trend is generally pretty positive. Another thing that I love to track is if you go to github.com and type Vulkan into a search box, how many projects do you find that mention Vulkan? I've been tracking this I check it about every 6 months, and it seems to go up by about 400 hits every 6 months. So there's a lot of stuff. This, by the way, we took 2 weeks ago, and there are now 82 projects beyond that. So the rate of growth is impressive. It's possible some of those hits are projects where they say, yeah, we tried Vulkan, but it sucked, so we stopped using it. But you know, I don't go and read them all. It's too many. But in general, it seems like a good sign. Another interesting data point, I'm not quite sure how seriously to take it, but Balder, who's the tech lead for RenderDoc, keeps track of, because it's market research for him, what are developers using RenderDoc for? And these are the stats that he has as of a couple of weeks ago. You can see that Vulkan is second only to DX11 as a target for RenderDoc use. Now, again, there could be many reasons for that, but it is kind of suggestive. It seems like there's a lot of activity, and the activity is growing. So, what's the working group been doing? Ta-da! We have Vulkan 1.1. This has been a project that's been kind of perking along in the background for 2 whole years. The way we do work on new specs these days is we don't think about, this is evolving, but we try not to think about what should be in the next core version of Vulkan. We think about what functionality do developers need in order to be productive to make Vulkan stronger and a more attractive target. So that means we write extensions. Generally, if you see the KHR tag on an extension, it means we take it as seriously as a core version. It is conformance tested, it is supported in validation, it's ratified by the board, which means that it is under the Khronos IP protection, policy protections. So KHR extensions are very, very serious. So what's in 1.1? Well, a whole lot of the extensions we've written over the last 2 years come into core with this. So there's multi-view that was put in partly to support VR, to do stereo rendering, also for, it has many other applications besides that. Cross-process sharing was put in originally to support having a VR compositor, which was outside Vulkan. And so we needed a way to share Vulkan resources with non-Vulkan applications and processes. Advanced compute functionality put in partly to support, you'll hear later from David about supporting other languages besides GLSL, doing more compute-y things, pointer support, and for platforms, YCBCR rendering. Device groups. One of the biggest holes we had that we had to apologize for when 1.0 came out was that we didn't have a good solution for SLI and crossfire type multi-GPU rendering. So device groups support that. I'm particularly proud of the fact that although this is something that basically is only used by AMD and NVIDIA devices, the whole ecosystem supports it, its core functionality in 1.1, and all of the even mobile vendors have implemented paths for this at significant effort. What this does for you is it means that you can write an application which will take advantage of multiple GPUs, if you have them, fairly seamlessly. And we think that's important. We're trying to allow your applications to be clean and not have this huge cliff you have to climb in order to put multi-GPU support in your applications. HLSL support, again, David will talk about that. And oh yeah, there were a significant number of bugs and a few bad design decisions in 1.0, which we have incrementally fixed over time. And all of those have been brought into 1.1. There are two things in 1.1 that were not previously exposed in extensions. One is protected content. I'm not sure how interesting this is to game developers, but I'll describe it briefly. The idea here is that you want to be able to write an untrusted application which can render using content that people might legitimately fear that application might try to steal, and to keep that from happening. So the idea is you've got protected memory, which has, and you've got unprotected memory. You've got protected accesses and unprotected accesses. And things are carefully set up so that it is not possible for the application, no matter what kind of access it makes, to copy data from a protected resource into an unprotected resource. This has to interact with the external sharing stuff because your typical application is, I get protected, say, video from the video decoder, and I render that to a protected display device without being able to siphon it off and sell it on eBay. So that's one thing. The other big one, which was a very strong developer request, is subgroup operations. I assume you all know what those are, so I won't explain them. Lovely pictures here. Thanks, Neil Trevitt, for those. The main thing to know if you are a DX12 developer, basically what we've got is we've got all of the DX12 subgroup operations plus a few. However, we only support them for 32-bit data types currently. We will fix that over time, but that's what we were able to define in time to get it into, to meet the shipping deadline for 1.1. So I think enough about that. So as I said, 1.1 is out there. As usual with our releases, we are trying with every release to raise the bar on delivering a ready-to-go solution. It's a work in progress, but we've done significantly better with 1.1 than we did with 1.0. So it is the case, the specs are out there. They are on GitHub, and you can contribute to them. You can raise issues if you see bugs or think they're, or just find them confusing. You can do pull requests against them, and we look at all of those. Conformance tests similarly are out as of 2 weekends ago, I think. And the whole tool chain, David will talk about the SPIR-V side of it, but GLSlang is on GitHub, DXC is on GitHub, the LunarG SDK, loaders, validation layers, etc. In terms of drivers, we went, again, significantly beyond what we did with the 1.0 release, that you can get installable 1.1 drivers from AMD, from Intel, from NVIDIA. And very exciting for me, the open source drivers, ANV and RADV, were conformant on the day of launch and are available. You have to go to Mesa to get them. Again, there's this pipeline. So, you do have to do your own install. It's a little bit crummy. And one more thing, I'd like to do a shout out to Samsung, who aggressively certified the Galaxy S9 and probably some other things as 1.1 conformant on the day of launch. So other things that have been going on, and some of these are very much the working group at work, and some of them are kind of peripheral or in associated groups. LunarG is a Colorado company that does a great deal of work on the Vulkan ecosystem and tool chain, and they're sort of the spearhead, the point of the spear on developing the SDK, the layers system. Historically, they've been the people who did all of the validation work, pretty much. We are taking that over, or we're taking over some of it in the working group. They're still kind of leading and project managing it. But a couple of things they've introduced. We always thought that with this, you all understand the layer system, right? You can have this built-in interception system that is integrated with the loader, so you can do traces and things like that. We've always had the notion that we would deliver some layers, but that also developers might want to do their own because they don't like ours, or because they have special needs, or they just want to do something. And that was the concept, but we found that developers were not really able to take advantage of it, because to write a layer, you had to know so much about how they work, and it was kind of not worth the trouble. So the Vulkan Layer Factory is a new product from the LunarG folks, which kind of automates, hides the details of how layers work, and lets you write one relatively easily. So that's out now. We're kind of working on maybe backporting that to some of the layers we've already done, which don't quite follow that abstraction. So that's an active project, and again, go to the LunarG website, you can check that out. Device simulation layer is a concept that we had way back before 1.0 released and finally executed on. Here, the idea here is, Vulkan, one of its besetting good thing, bad thing sins is it's got a lot of caps. And you have to do lots and lots and lots of checks for what does the particular thing I'm running on, what can it do, what can it not, what are its limits, et cetera. And the validation layers will check and tell you if you exceed those limits, so that you get some kind of decent error message. But you had the problem that, let's say I'm developing on some great big honking Vega or Titan card, and it's got enormous capabilities, but I'm actually trying to target a low-end Intel integrated implementation, or I'm trying to target a mobile implementation, which has very different limits. So what the device simulation layer does is it allows a more capable device to load in, that allows the driver to load in a configuration file and pretend to be a less capable device, so that validation will catch anything you do that exceeds the limits or capabilities of the implementation that you actually want to run on. So that's kind of nice. And then the most recent, the assistant layer, very much a work in progress, and it will be built out over time. But this is two things. One is it attempts to notice you doing things that are suboptimal from a performance point of view, and it's also kind of a linter. It watches for you doing things which are legal, so they don't trigger validation warnings, but they're questionable and potentially indicate that you might just have a little problem there. And as I said, this is all at the LunarG Vulkan SDK, and it's all in open source. One other thing that the working group's been doing, we take conformance testing deadly seriously. We view driver bugs and driver implementation inconsistencies quite seriously as an existential threat to Vulkan. If you can't trust your driver, well, you can't trust your driver. But we want you to be able to trust it. We want to make it better continuously over time. Khronos invests very heavily. It's our largest single engineering project inside the organization across all of the APIs that Khronos works on. And I believe that we're doing less than half of it. Our member companies, Google, Valve, the IHVs, et cetera, I believe are investing even more than Khronos is. So I get Alexandra Galatzin, who's the tech lead for the conformance group, to feed me statistics again about every 6 months. And this is the number of thousands of test cases in the conformance test over time going back to the fall of 2016. And what I hope you notice is that it's roughly doubling every year. We probably can't sustain that. It's probably going to be arithmetic, not geometric, or not exponential. But just as an indication, we're doing our very best. And again, this is open, and if we are testing the wrong things, you are seeing stuff, it would be awesome, of course, if you give us a detailed bug report and example code and contribute a test to solve the problem, but we know you're busy. If you can't do that, just go to the GitHub site, file an issue saying, I'm noticing that these things are inconsistent. Validation doesn't pick them up. I think I'm doing stuff right. Can you please help? And we will definitely take a look at that. So last thing I'm going to talk about, one thing that's been really striking to me as we moved from, because I used to chair the OpenGLES group, we were, I think we were nice people, but we were relatively, we kind of hid in our corner and did our own thing and considered that we owned the whole API and tried to make it useful to people, but we were kind of kept this wall up. With Vulkan, we're trying very, very hard not to do that. Doesn't come entirely naturally. It's a work in progress. We ask for your patience. But what we are seeing, and it's very awesome and very exciting to us, is that the ecosystem, when we adopt this more open stance, the ecosystem grows faster, and that is fantastic. So one thing that's been striking to us is that as the ecosystem grows, it's getting more and more complicated. And, you know, I tried to draw a block diagram, and it was completely, it was like looking at the Tokyo subway. So I gave up on that. But, you know, you can kind of break stuff down. There's stuff that is clearly our job. We write the specs. We write the conformance tests. And in future, we're going to write at least initial validation, although we think members are going to do a lot of that work as well. There's stuff that we work in, you know, we're tightly coupled with, but that don't happen inside the working group, like the LunarG SDK, the GL Slang compiler, DXC, the SPIR-V tool chain. And there's tons of cool stuff that happen completely outside us, and we kind of have to work hard and pay attention to even know that it's happening. So, well, RenderDoc, we're pretty well aware of that because I hope all of you are pretty well aware of RenderDoc. Very, very useful tool. There's cool stuff like Sasha Willems' code examples and, you know, GPU info database. Khronos doesn't do anything to make those happen. They happen because the people involved want them to. We're very grateful for that. It's cool. And as I said, there are many other things. And a gross oversimplification, what this means is really I've binned stuff out here, but really there's tons of overlap and it is very complicated. That's great, but it's a problem because it's hard for you as a developer to navigate. So you find, sorry, need to keep track of my time. You're using lots of tools in your development, and you find things aren't working well together. What do? If it's clearly a bug in a tool, you can report it to the website for that tool, because they're mostly open source, and you'll probably get some action out of it. But very often the problems you have are interactions, and it's not obvious what is causing that, and you don't know where to go. The same problem happens for people doing tool development. If lots of us, our dev tech engineers, are hearing from users that there's a problem in the ecosystem that needs to be solved, there's typically more than one way it could be solved. You could add a feature to this tool, you could add a feature to that tool, you could change them. It's not obvious what you should do. So it's tricky for developers, it's tricky for the tool builders. So we're attempting to address that by something new. This is, has been in the works for 4 or 5 months, but is now, we're going public here at GDC, the Vulkan Ecosystem Forum. So this is something Khronos has not done. Typically, Khronos groups are NDA only, and you have to be a member and stuff. The Ecosystem Forum is not. It's explicitly public. Anybody can participate. It is particularly aimed at bringing together the people who are tech leads for tools and the working group and the developer community to try to talk about these issues. It's particularly aimed at, you know, as I said, if you've got a problem that could be addressed in multiple ways, how can we work together to get an efficient solution rather than having things kind of go off in random directions? To be very clear, we're not trying to control any of this. All these projects are their own thing. They decide what to do. We're just trying to help and provide a place for people to talk. Some examples of things that we're doing. There was an observation and a lot of reports from people saying, HLSL, yeah, there's DXC support, there's GL-SLang support, and there are lots of bugs and issues. What can we do about that? And the answer turned out to be bring together the stakeholders, set up a dedicated side meeting for that, and have them talk together and work together. Also, work on the SPIR-V validator, which is a tool which takes SPIR-V coming out of your tool chain and tells you if it's got things that are syntactic or semantic errors, according to the definition of SPIR-V. Another thing we're doing is just trying to build a map of this very complicated tool chain landscape. You know, a typical problem, I've got a tool which kind of assumes that you're using a particular compiler and tool chain, and I've got another tool I want to use which assumes a different compiler and tool chain, and I can't use them together. Well, we're trying to address that kind of problem. So the main way that we expect that developers will interact with this is if you see a problem in the ecosystem, please go to the GitHub site, Vulkan Ecosystem, raise an issue and say, I'm noticing this. Everything gets read, everything gets looked at. Sometimes it takes a little while, but we will get back and tell you what's happening with it. There is also a regular weekly phone call. There's a mailing list, which you can sign up for at the Khronos website. And there's a weekly phone call at which we get people together. Mostly what they're doing, as I say, mostly the people who attend the calls tend to be dev techs from IHVs and tech leads from tools, and they talk about the administrative grunch of how do we make this work. You are welcome to call in. It's just, you know, is it going to be useful and interesting to you? You have that question. There are reasons why you might want to. I would like to, because I didn't get a profile pic of him to put here, I would like to ask Nuno Subtil to stand up. Nuno is a dev tech at NVIDIA. He's the chair and also spearheaded formation of this group. So recognize him, come and talk to him later if you are interested. Thank you, Nuno. And you can find out more about how that's going. So that's me. I should say, we talked about this from a bin packing point of view. We decided that it's better to have one big block of time for Q&A at the end rather than a bunch of little ones, because you all know how bin packing works, right? Okay, so without further ado, please welcome David Neto.
Hi, who out there this is your first GDC? All right, well, welcome. Let's talk about shader tooling. So Tom alluded to the complicated ecosystem that exists around Vulkan. This is the ecosystem around SPIR-V. SPIR-V is the language in which you send shaders to Vulkan. That's a lot of stuff. It's a lot of activity. I'm going to focus on a few paths through this and give you some more information that'll help you navigate this and make your life happy. All right, so let's talk about how you get shaders into Vulkan. So most people want to write shaders in their existing shading languages, GLSL or HLSL, or you might have a domain-specific language or something from something else that you want to have your own compiler. Well, SPIR-V is there to be the vehicle where you translate that with a compiler into SPIR-V, and then you hand that off into Vulkan. SPIR-V is fairly general. It's used for compute APIs. OpenCL is the Khronos API for compute. And every environment like Vulkan, for example, defines the dialect of SPIR-V. What rules does this SPIR-V blob have to follow in order to be acceptable to Vulkan? So that's why I got the little V on there. So the compiler has to generate SPIR-V, which can be consumed by Vulkan. So the dominant shading languages clearly are GLSL, defined by Khronos, and it's a standard, and you can read its spec, and there are compilers out there. But we know that there's a lot of content written for HLSL. Microsoft has done a great job with their shading languages. And we want to make sure that you can bring that content to Vulkan as well. So let's talk about how you get some translations into what you need here. So there's two main compilers that exist and are working today to get your high-level shading languages in. So there's GL-SLang, which is maintained by Khronos group itself. And then there's DXC, which is Microsoft's new shader compiler. And then I'm going to talk about what SPIR-V is. And those are the ways you get the shaders into SPIR-V. Clearly, GLSL, there's only one path in, but for HLSL, you have a choice. And I'm going to give you guidance in a minute or two about which path you should take and why, because there's trade-offs that we want to talk about. So both these compilers are open source. So what's the backstory on GLSlang? So GLSlang started out its life as the reference parser for GLSL and the embedded form of GLSL, known as ESSL. So that's the place you go where you know, is this supposed to work on my driver when I send it there? Now, in the development of SPIR-V, we added a code generation phase to the parser to actually generate SPIR-V. And this was done over a couple of years to make sure that SPIR-V actually expressed all the things it needed to do. It was a proof of concept that it was a sane spec. And so GLSlang has become the de facto compiler for GLSL into SPIR-V. And because of that, it was also developed as the compiler that's used for the vast majority of tests in the Vulkan conformance suite. And so whenever a new programming model feature comes along, such as subgroups that Tom just talked about, the working group will define what semantics does this have, how does it map into GLSL, and then for writing conformance tests to make sure that it works on everyone's environment, we write tests that use GLSlang to translate that GLSL into the test and make it run. So on day one, you're going to get a spec, a working version of GLSlang that implements it. And so new programming model features in Vulkan are always going to land in GLSlang first. Now, along the way, we said we wanted to make sure that HLSL content was also available in to Vulkan implementations. So a project was undertaken to add HLSL code generation to GLSlang. And so now Valve and other companies have contributed their workloads that have lots and lots of shaders, which then go through GLSlang, they make sure it gets compiled, and Valve has had a lot of success in shipping their applications. So I would call GLSlang's HLSL path the first mature HLSL to SPIR-V compiler. Now DXC, this goes back 2 years at GDC 2016. Microsoft announced that they would be transitioning from their old shader compiler stack, which is proprietary, to an open source shader stack, which they're calling DXC, which was a tremendous day, a lot of excitement in the ecosystem. They released the source code, the first version of their source code, about a year ago, and we took a look at that and said, this is a golden opportunity to leverage Microsoft's work in, and as they're taking HLSL forward, to have a Vulkan backend to that. So that's what SPIR-V is. It's the idea of, can we contribute code generation for SPIR-V or for Vulkan? And that's what we've reached out to Microsoft. They've been very helpful to us, and we've been contributing these code patches to them, and it's been a great working relationship. So the key thing is that we're using all of Microsoft's parsing of HLSL, and we've just tacked on a backend, and this code is now available, and it has been developed out in the public directly in Microsoft's GitHub repository. It's been a great working relationship. So now you've got a choice when you're compiling at HLSL. You have to say, well, what am I going to do? And the answer is, unfortunately, it depends. There's no perfect compiler for every situation. So let me walk you through 3 kinds of criteria you might want to think about. In terms of language coverage, so these are both open source compilers. HLSL does not have a spec, and so the compiler is going to support whatever it is that the contributors to that code are trying to run through their flows. So if one company is going to have some engine which is going to produce all sorts of HLSL that looks a certain way, that's going to work through that flow. And it just historically has been that the GLSlang part of the HLSL code generation has primarily worked on Shader Model 4 and 5.1 historic environment code. And so that's kind of where it shines, and that's its focus. The DXC SPIR-V one has been exercised on a different set of shaders, and so it's kind of in the 5.1 and 6-ish kind of zone. So that can evolve over time, and it all depends on what workloads are thrown at these compilers and what contributions are made to these open source projects. And then the second part of language coverage is, as I said before, GLSlang, because it's using conformance tests along with the development of a new programming model feature, new Vulkan programming features are going to land in GLSlang first. And another attribute is that the DXC SPIR-V is always going to be Microsoft's definition of HLSL, no matter what that is. Now, the new features will land on GLSlang first, but with something like subgroups, my team knew that subgroups was going to be really important. So we got the public spec and implemented subgroups within a couple of days. So we think that as long as there's a feature which is going to map to Vulkan, we're going to have both compilers tracking that feature set pretty well. Now, you also will care about what platforms do you need your code to run on. GLSlang is totally cross-platform. Every platform you might want to run it, it's great. DXC runs on Windows. And I wish it ran on more, but that's just the state of things today. In terms of code size, now GLSlang was this very focused thing. It's custom built for the Khronos defined languages and now the HLSL part. So it tends to be rather small. It compiles really fast, just a few seconds. And so you can think of the kind of, it is the kind of thing you might want to ship with your application and have run on the target device. If it's mobile, it will work there. DXC is a fork of LLVM and Clang with some parts torn out, but it's still a rather large piece of code. So it's a big binary. And so you might want to take that into account. You may not want to ship that on mobile. So these are all, there's various reasons why you might want to use one versus the other. But we're trying to make a good experience in all these cases. All right, so enough about HLSL compilation. Let me talk about another flow through that diagram. So let's say you have your SPIR-V, and you want to take a look at it and understand it, and you don't want to become an expert in SPIR-V assembly code, because it's very detailed. So there's another Khronos-led open source project called SPIR-V Cross, which can be used for inspecting a module, looking at its binding information, but also, very importantly, you can take an existing shader that was intended to go to Vulkan and then map it back out into HLSL, GLSL, and metal shading language as well. And that's been kind of a cool tool for people to understand what's going on. How did this get through my compiler, which might have transformed my code? What's the back end looking at? And also, the MSL path of this has been useful for one team to actually build something which is useful that Dan will talk a little bit more about, Molten VK, for accessing Apple platforms. And then finally, another project that is maintained on behalf of Khronos is SPIR-V Tools. It's a toolbox of things that lets you assemble, disassemble, and validate SPIR-V. And also, there's been a lot of activity the last 8 months or so, actually more than a year, to have it have what you might call an optimizer, or it's a toolbox of transformations. And this is actually embedded in GLSlang and in DXC SPIR-V to transform the code behind your back, do optimizations, get rid of redundant loads and stores and that kind of thing. And this is available to anyone to do custom transformations if you want. So there's a whole framework that you can use to transform your code. So this is, I think, a very useful project that you might want to look at. And I just want to say thank you to everyone who's involved in the ecosystem. And I'm going to give a plug to the talk that follows this one about HLSL in Vulkan, where a lot of this will be gone into in more depth. And now I'd like to welcome Dan.
All right, thank you. So my name is Dan Ginsburg. I work for Valve, and I'm going to talk today about what we've been doing inside the Khronos Portability Initiative for Vulkan. So as Tom mentioned in his talk, Vulkan has achieved widespread pervasiveness. Nearly all of the major GPU companies have drivers. It's supported on a wide range of platforms, Windows 7, 8, 10, Linux, Android on mobile phones and media players. Just recently, the Nintendo Switch passed Vulkan 1.1 conformance. At Valve, we've used Vulkan to enable VR and Steam VR. On Linux, the entire stack runs through Vulkan, both the compositor and the client. On Windows, the client is based on Vulkan, and we use the Vulkan external memory extensions for interop. The Oculus Rift supports Vulkan clients, and cloud services and embedded as well. So Vulkan is pretty much everywhere, pretty much. But one of the major questions we get asked in the Khronos group is, what about Vulkan on Apple platforms? As all of you know, Apple has developed Metal, their own graphics standard. And up to this point, they haven't supported Vulkan. But finally, we can say there is some support for Vulkan on Apple platforms, on Mac and iOS. But I want to say that there are some caveats. I'll get into those in detail. It's not a conformant Vulkan implementation. What we're doing is layering Vulkan on top of Metal. So of course, we're limited by what Metal can do. But the good news is that the limitations aren't that big, and the performance we're getting is actually really good. So back in February, we announced the open sourcing of Molten VK. So Valve has been working really closely with the Brenwell workshop that initially developed Molten VK as an open source, as a commercial project. And we've worked with them to get it out into the open source community. And you can get it now from GitHub. It supports Vulkan on top of Metal on macOS and iOS. And it's licensed with the Apache 2.0 license, which means you're free to use it in commercial products. So it's a very liberal license. We also thought it was important that developers have access to the same kinds of tools they're used to on Windows, Linux, and Android for developing on macOS. So LunarG released the first macOS SDK, which ported the loader over to macOS, and importantly, that enabled validation layers. So the same validation layers that run on Windows and Linux and Android are available on macOS. And several of the tools have been ported as well. At Valve, we've been working really closely with Molten VK, and we have our engine Source 2 ported over to run on it. We have Dota 2 fully up and running, and we're getting a really good performance increase in CPU-limited situations versus our OpenGL renderer on macOS. We're seeing as much as a 50% performance increase, and we're seeing it across the board on AMD, NVIDIA, and Intel-based Macs. So I wanted to show you a quick video of our Vulkan renderer running on macOS. This is Dota 2. The Molten VK renderer is on the left, and on the right is our OpenGL renderer. And as you can see, we're getting quite an improvement in frame rate. This is on an AMD D500 GPU running at 720p at our highest quality settings. And so all of the rendering features that we have in Dota, they all work on Molten VK. And we're really excited about shipping this to customers. We think it's going to improve the experience for Dota 2 players on macOS significantly. And importantly for us, we were able to leverage our Vulkan renderer, which we've spent a lot of time developing, and bring it over to Molten VK and have it work without a whole lot of effort. So a bit more detail about Molten VK. It's designed to be a low overhead implementation of Vulkan on top of Metal. Now, by that I mean not every single corner of the API, the Vulkan API, is implemented. Only those things which can be done efficiently are done. Just as one example, Vulkan supports very flexible texture swizzling, and Metal does not. And in order for Molten VK to implement that, it would have to do runtime shader patching, which would just crush performance. Philosophically, we don't want Molten VK to do that kind of thing. It's intended to be fast. So it implements only what's possible on top of Metal. There are some cases where Metal doesn't provide something in the API that Vulkan does that are easy to implement, or at least have efficient implementations. So for example, Vulkan has very flexible blitz. And Metal's blit encoder is much more limited. We can do scaling and filtering. And in that case, Molten VK will generate its own shader internally, generate a render pass, draw a quad, and implement the blit that way. So there are limitations, and we're working to formally define those within the portability working group. I'll tell you a little bit more about how we're doing that later. But a lot of things do work. And it's supported on macOS 10.11 or greater, on iOS 9 or greater. As David mentioned, we're using the tool SPIR-V Khronos, which was developed by Hans Christian Arntzen, who's here in the audience, just waved his hand. It's an awesome tool. So Molten VK links this in. And what happens is at pipeline creation time, the SPIR-V shaders are converted to the Metal shading language. One of the things that we're working on inside of Molten VK is to implement the VK pipeline cache so that the MSL that's generated from SPIR-V can be stored on disk by the application. We're going to do that before we ship Dota. I also wanted to mention that there's also a Molten VK specific extension for providing metal binaries directly, which means you can do all of your shader compilation offline and have as fast as possible of pipeline builds. A bit more detail on the LunarG SDK for macOS. As I mentioned, the loader was ported, and the way it works is that Molten VK serves as the installable client driver. So whereas on, say Windows or Linux, the IHV provides their driver and the loader loads it, in this case, Molten VK is the ICD from the perspective of the loader. The validation layers are then injected into the call stack in exactly the same way that they are on Windows and Linux, and applications can therefore enable validation layers in the exact same way. You can use environment variables just like you can on Linux and Windows, so it's very easy to use. There's basically two methods of how you can deploy your application with Molten VK. One is you can just drag a framework into your Xcode project and statically link against Molten VK and then run directly with it. You can also dynamically link against the loader and Molten VK and put those in your application bundle, and the loader will load the Molten VK ICD when you run your application. So either ways of deployment are supported, and those are outlined in the documentation for the macOS SDK. A bunch of tools are also provided, like shader compilers, some applications like Vulkan Info. LunarG is working still on getting some more tools like VK Trace and VK Replay into the macOS SDK, and the idea is we want to have all the same tools that we have on other platforms. I should mention too, by the way, that you can use the Metal GPU frame debugger and see exactly what Molten VK is doing, and so you have access to a GPU debugger right out of the gate, and I found that very useful when I was bringing up our renderer. So within the Khronos Portability Initiative, we're not just thinking about Metal. That's one platform. Another is D3D12. So the reason we care about D3D12 is that in some flavors of Windows, Universal Windows Platform applications, or UWP apps, don't have access to Vulkan or OpenGL. And this is really a problem for applications like Firefox Quantum from Mozilla, who want to be able to have a Vulkan-like API, but don't have access to Vulkan drivers. So Mozilla is developing their own portability implementation that's going to run not just on Metal, but also D3D12 and OpenGL, and that'll be used inside their browser. We'd also encourage any other developers out there that want to implement the portability subset to work with us. We're interested in working with you if you have your own that serves another market need. So where we are right now is that we have a draft for a Vulkan portable subset definition, and this basically defines the features and limits of what is not natively supported in a portability implementation. And the list of them this is basically all of them that we've identified so far. So things like triangle fans are not supported, those aren't in Metal, separate stencil reference masks. The Vulkan event functionality doesn't map very cleanly to Metal, we don't have support for that. Limited texture swizzles. Allocation callbacks where the driver calls into your own callback to allocate memory. We can't really support that for the driver because we don't have access to, say, the Metal's allocator. We can only do it within Molten VK. So as more underlying API features are available in Metal and DX12 or DX13, whatever, these features may get supported in the future, but what having a formalized definition will mean your application can check at runtime whether these features are available and respond appropriately. It means we can have validation layers that check it, and also the device simulation layer. So where we are today is we've shipped the open source Molten VK, the macOS SDK. In the future, we're looking to widen the platform support to DX12, and Mozilla's working very closely with us on that. We'll have validation and device simulation layer support. And ultimately, where we want to go is we want to have a version of the conformance that tests the portability subset that can verify that an implementation of the portability subset actually is conformant. And we're not there yet, but we hope to get there. So everything I've mentioned in the presentation as far as downloads you can get to from the Vulkan Portability landing page. I'd encourage you to check out the Molten VK GitHub repository, as well as the macOS SDK from LunarG. And if you test your Vulkan workloads on Molten VK and you find issues, either performance or functionality, please file bugs. We want to try to get it as solid as we can, and we're really interested in getting more workloads on it. Additionally, if you have any feedback for us on what we're doing inside the Portability Initiative about what things you want to be, how you want us to specify the subset, things that you think are important to be in the subset, you can also give us feedback at this link as well. So I think that's all we had, and I'm going to ask Tom and David to come back up for any questions on any of the talks that we had.
Okay, so there's a microphone in the middle of the room. I have a flaming hot text message from my buddy Alan Orbach at Samsung saying, by the way, if you go buy a Galaxy S9 today, it will not have a 1.1 driver on it. They have submitted conformance results and passed them, so there is a conformant driver for it. It's not in shipping devices. Sorry about that. Yes, please.
Back in 2014, Google broke front-end compatibility for OpenCL. Basically, on OpenCL on Android just doesn't work anymore because Google chose RenderScript over OpenCL, and OpenCL compiles to SPIR-V. What's to say this is not going to be the fate of Vulkan and compute shaders, which is severely limited compared to OpenCL? There's a whole bunch of OpenCL 2.0 features which aren't in Vulkan. I get it, it's a rendering API, it's not meant for compute, but there are certain things you can do in terms of machine vision and all kinds of other stuff, right? So eventing API, lots of the stream processing APIs are broken. So I'm just concerned about adopting something like Vulkan on Android on multiple platforms and then having it broken because a vendor decides their front end can't support it.
Do you want to take that or shall I?
I'll say one thing. OpenCL was never part of the Android platform. So Android's an open system, and we give it out, and companies like Samsung and others modify it. And so when OpenCL appears on such a device, it is because that extra vendor decided to put it there.
The NDK explicitly broke compatibility. There's a bug filed by Chris Hines. You can look that anyway. The point is, look that up.
That does sound like a bug.
Okay.
I don't know anymore.
The other thing I will say is that we have a pretty well-developed compute roadmap. I took out the slide I had about CLSPV, which was about the Adobe Google effort to run Adobe 200,000 lines of Adobe OpenCLC shaders, which do run on top of Vulkan. It is not everything, and there are things in CL 2.0 that will probably never do. Sorry, next.
I was wondering if there's any chance in the future of getting the OpenGL interoperability extensions for Molten VK, because using third-party libraries that only know how to render OpenGL it still limits you. If you want to use Molten VK and you still integrate with one of those third-party libraries, it becomes a blocker.
Sorry, so the question is interop between Molten VK and an OpenGL application on macOS?
Yes.
I have not given that any thought. I have heard of other people doing that between Metal. Assuming it's possible to do between Metal and OpenGL, I'm sure we could put an extension into Molten VK. I just don't know the details of whether, how technically possible that is. But file an issue on GitHub and we could take a look at it.
Will do.
Yep.
Hello. I was just curious about the versions of GLSL you guys support on Molten VK.
The versions of GLSL?
Yeah.
So we don't support GLSL directly. The way that shaders are compiled is that you use the same SPIR-V that you would use in a Vulkan 1.0 application. The SPIR-V Cross takes that and converts it to MSL. SPIR-V Cross does have a backend for GLSL and HLSL as well. We use that just to sometimes check that the MSL matches the GLSL, but it doesn't actually use it directly. So it's basically SPIR-V Vulkan 1.0 SPIR-V 1.0 is what it supports right now. But it's mainly limited by what SPIR-V Khronos has and what the MSL compiler can do.
Okay, thank you.
Yep.
One other smoking text message, a thing which I forgot to put on my slide. When we're being excited about the state of Vulkan, the release of Vulkan 1.1, I forgot to mention that if you are an Android developer and you have access to the Android P developer preview, that has Vulkan 1.1 headers in it, so that is going to be officially supported. Any other questions?
So there's Vulkan on Android, there's Vulkan on the PC platform. Is there any chance we're gonna get Vulkan supported in the Android emulator, the emulator that runs in Android Studio? I mean, the mapping sounds straightforward.
So I don't know when that will occur. I presume somebody is working on it. Google is a large place, and I don't know. Sorry.
Anything else? Okay, remember to come back in 20 minutes, I believe, for the session on HLSL in Vulkan. Thank you all very much for coming. Please talk to us, file bugs, grab us here.